All right, let's crack a classic GCSE geometry question that's got a bit of a hidden twist. Our goal isn't just to find the answer, but to really think like an examiner and write down exactly what they need to see to give you every single mark. And here's the puzzle right from the start. The question asks for an expression for angle CAD, and the diagram clearly labels it as just E. But then you look at the official mark scheme, and the answer is 180 minus 4E. So how on earth do you get from a simple E to that? Let's figure it out. Okay, first things first. We have to decode the question. Let's break down exactly what we're being given. Because in geometry, every little piece of information is a clue. So the question gives us two key things. First, the shape ABCD is a parallelogram. That's a huge clue right there. And second, we have a couple of angles given in terms of E. Angle CAD is E, and angle BAC is 3E. And this brings us right back to that central mystery. The question asks for angle CAD, but the diagram literally points to it and says this is E. So why is the mark scheme giving a totally different answer? There's clearly more going on here than meets the eye. We need to dig a little deeper. So, section 2, those clues in the parallel lines. The key to this whole thing is in that one word, parallelogram. The properties of its parallel lines are exactly how we're going to solve this thing. Okay, so a super quick refresher. A parallelogram is just a four-sided shape where the opposite sides are parallel. That means line AB is parallel to DC, and line AD is parallel to BC. This is the property that is going to unlock the entire puzzle. Now let's actually use those parallel lines. If you look at the diagram, can you spot the Z shape? It's formed by the parallel lines AB and DC, with the diagonal AC cutting through them. This Z creates a special relationship called alternate angles. And here is our first crucial geometric rule, the one you literally need to write down for the examiner, word for word. Alternate angles are equal. So if we apply that rule to our diagram, we can see that angle ACD is alternate to angle BAC. And since we know angle BAC is 3E, we've just found another angle. Angle ACD must also be 3E. That's our first calculated step. All right, next section, calculating the angle. Now that we found that angle ACD, we can use it, and what we already know, to figure out one of the main corner angles of the whole parallelogram. Let's focus on that big corner angle, DAB. You can see it's just made of two parts, stuck together, angle CAD, which is E, and angle BAC, which is 3E. So you just add them up. E plus 3E gives us 4E. A simple step, but absolutely vital. Okay, now let's use the other pair of parallel lines, AD and BC. The two angles that are kind of squished between them, DAB and ADC, they also have a special relationship. They're called co-interior angles. And here is our second key rule to write down for the examiner. Co-interior angles add up to 180 degrees. This is a fundamental property of any parallelogram. So let's apply that rule. We know that angle ADC plus angle DAB has to equal 180 degrees. And since we just figured out that DAB is 4E, a little bit of algebra tells us that angle ADC has to be 180 minus 4E. So section 4, solving the real problem. We've got our final expression, 180 minus 4E. Now, how does this actually solve the mystery of that original question? And there it is, our calculated expression, 180 minus 4E, perfectly matches the official answer. But hang on, notice this is the expression for angle ADC, not angle KAD. And that is the solution to the mystery. The exam paper had a typo. It asked for angle CAD, but the calculation that was actually required, and the answer in the mark scheme, is for angle ADC. You know, it's a classic exam paper error, and knowing how to navigate it by just solving for what's logically required, that is a top-tier exam skill. Okay, section 5, how to get full marks. Because knowing the answer is one thing, but how do you actually write it all down to guarantee you get all 3 of those marks? This is the official mark scheme, and it's basically the examiner's playbook. It shows us exactly how the marks are awarded. You see M1 for method, A1 for accuracy, and C1 for communication. Let's see what you needed to write to get each one. Okay, to get that M1 method mark, all you had to do was show a correct first step. For example, just stating that angle ACD equals 3E because of alternate angles would get you that mark.
For the A1 accuracy mark, well, you needed the correct final answer, 180 minus 4e. And finally, for that crucial C1 communication mark, you had to write down the geometric reason, like alternate angles are equal or co-interior angles add up to 180 degrees. You need all three for the full marks. So what's the big takeaway from all this? In geometry, you can't just write down the answer. You have to prove how you got there. You've got to show your intermediate steps, like finding that angle DAB is 4e, and always write down the geometric rule you're using. That is the formula for turning a tricky question into guaranteed marks. So the secret is just spotting these potential errors, trusting the geometric rules, and clearly showing your work. Now we want to know, what's the most confusing exam topic that we should explain next? Let us know.